Good, Marshall. All good to go.
Excellent. All right. So what I'd like to do is we're going to talk about why top financial institutions fail at artificial intelligence. And I think that's a very appropriate saying for kind of capturing the dynamics of what my talk is going to be about. And it's not just based on sort of a moment in time. It's not just based on sort of this last year or this. It's actually based on something I've seen historically through everything from the subprime mortgage crisis, where I was a trainer, all the way through today. So I'm going to start with a very simple business problem to kind of illustrate this concept. Teams read thousands of reports, spend a lot of wasted time, bias in their analysis. In this conference itself, we spend a lot of time talking about, causal AI and a variety of other sort of things. And I think correlation is always misconstrued with causation. And so one of the solutions for this particular business problem was maybe you could use natural language processing. And this is something that popped up about 7 years ago, actually. I remember going to a Wall Street firm, and I remember there was like 16 people kind of dedicated to NLP. And they were all like, oh, we need to build an NLP type system. So here's a little glimpse into an example. So if you had some text, right, in an unprecedented move, the NASDAQ has hit new records today following news of a new vaccine. Is that a positive statement? Is that a negative statement? Another example is the FTSE suffers dramatic losses on the back of the pandemic. And as we all know, social media has a very large impact nowadays on our stock prices and the volatility we're seeing in the markets. So traditionally, what we would do is we would squeeze that in. We'd have like full-time analysts sitting there processing these things, reading those, converting those into KPIs that would then use to kind of drive systems that evaluate things like risk, or forward returns, saying, hey, is this something we need to account for in our portfolio construction problem? Is there something that we need to account for in terms of upgrading our infrastructure and see if there's any kind of follow-up needed? So the alternative is you could sit there and buy it off the shelf or try to build it yourself, right? So the question for you, and I'm just going to kind of pose it as a rhetorical question right now because of the time. What is the modeling efficiency of data science teams if they had to build something like this? So what I found, and this is a quote from an executive, is AI modeling efficiency is about 5%, which was a really interesting quote. Now, granted, it's all nuanced depending on which department you're in or depending on which bank you're at. But they said 95%, this is the definition of sort of like efficiency, is 95% of the models do not end up in production. The question is why? So why is the efficiency so low? And there's a whole range of reasons, and maybe there's some data challenges, and maybe there's a compliance issue, explainability models, maintainability challenges, scalability challenges. There's a whole range of reasons why artificial intelligence models don't end up in production. But I see the most important one that I've seen come up over and over again, and it's overlooked by a lot of banks, is the explainability piece of it. And the explainability piece is not just a sort of qualitative, oh yeah, I get what the model is saying. A great quote that kind of captures this was said by an executive. For about 10 lines of code, you end up with about 50 pages of documentation. And that's a common theme through a lot of Wall Street, especially when you start incorporating in like the governance team, the second line of defense, in terms of actually building up your in terms of evaluating sort of the efficiency at which you end up in production. So the question for us is, why did the data science team fail? So here's an example. They go through the traditional pipeline, they bring in some data, they build up a model, and they ended up with about a 70% accuracy. So I want to take a minute here and actually use MATLAB to show you how quickly it is, how easy it is to kind of build up an example model. So in this case right now, I'm just going to load some data in. So I'm going to do this live. So I have some data right now in MATLAB. Working capital, total assets is this first column right here, retained earnings, and you have a rating right here. So if I had to build a model that captured all of these core factors and try to predict the rating, And I know this is the classification model, but the ideas of explainability are something that I'm going to try and focus on. Is I'm going to use an application. So there's a little classification learner app right here. I'm going to open it up. And what I'm going to do is map my independent variables to my dependent variable. And so all I'm going to do this is grab the data, which is this data variable right here. And you can see here I'm doing it in a few minutes, a few seconds actually. So data. I'm going to choose the predictor variables. I'm going to choose the validation technique. And the validation technique is kind of important, especially when you start talking about like out of sample and in sample type stuff. But even before doing any of that, sometimes it's useful to get a feel for what kind of accuracy could I achieve. And so this is now it's becoming a commoditized thing where you can literally get push button solutions where I can choose from a whole range of different types of models, everything from Gaussian, naive, Bayesian type approaches to decision trees to a variety of other ones. I'm just going to choose all quick to train, turn my parallel computing on, click on train, and it's actually going through and training up my models. And I have my parallel computing running, so it's going to be running multiple models at the same time here. Okay. And so on the left-hand side, you can see they're being queued. So you can see there's a couple of them turning on at the same time. And you can see the accuracy now for the first one, the decision tree is about 73.3%, 74% for the second one, and the other ones are being trained as well. All right, so this is the first step, is you build a model of some kind and you have to be able to explain this to your boss. And so then you might pull up something like a confusion matrix, which is, a lot of validation techniques already built right here. So I can see that. Let's take the triple Bs. 773 triple Bs were correctly classified as triple B, which is great. And I can see that if I looked at the true positive, I might get a percentage. I might be able to explain it in terms of these metrics. But the fundamental question for us on the explainability side is when we start thinking about data, this is the problem that ends up occurring, is these data science teams fail to communicate, with the executives. And an example is BlackRock Shell's unexplainable AI liquidity model. And the reason is no transparency to the process and code, minimal communication with the executive team, heavy on research without sort of like a focus on the business impact results. There's long email threads heavy on data science terminologies back and forth that we had to actually go through. So this is actually a real example that I'm kind of pulling up here. No communication with the model governance team until the model is sort of built. There's no even thought about sort of the governance team. No clear articulated plan for validation. And minimal to no model explainability. And so a little quote that kind of captured this dynamic was Risk USA said, the senior people wanted to see something they can understand. This is the head of liquidity research at BlackRock. So at MathWorks, what we try to do, and you'll see this through our applications, is we really focus on how do we get this to you faster? How do you get a feel for things faster? We ended up with models that ran in production at 86 to 87% explainability, with Shapley kind of like helping us with the explainability metrics. And in the interest of time, I'm actually going to show you a little glimpse into, in the last few minutes or so, a little glimpse into what we can do in some of the more complicated modeling spaces. So if you have an example, in this case right now, I'm going to pull up a little application here where it's live. I've connected this up to Twitter right before this. And you can choose, let's choose something fun. So Trump and Hillary are two common people who tweet, or at least there's tweets on there. So I'm going to run this. It's actually pulling data live right now from Twitter. So I'm not sure how much Trump is considered the social media president, is actually tweeting at this moment. He's probably not, but there might be tweets about him. And so you can see here, if I just kind of look at the sentiment scores that are being produced, you can see there's a heavy negative tailwind with a heavy density in the negative zone, which are just basically an aggregation of the tweets themselves. So the question for us is like, why is this actually, how is this impacting our analysis? How does this actually impact our stock prices? So to answer that question, I do have an example here that I captured to kind of give you a feel for things. And then I'm going to touch on the explainability piece in a second. So I use my little sentiment analysis tool in which I load up sentiment scores. And I'm going to compare the sentiment scores against the prices. So I'm going to pop that out. So you can see here, this is Google's sentiment score in red and the stock prices in blue. Oops. Let me zoom in. And so you can see here, there's a little bit of there's a significant lag right here. So if I look at the start of this fall of the sentiment score that started on September 7, 2017 at 4 o'clock, and then the fall on the prices happened about 5 hours later when the markets opened. So what we're hearing as a general theme is there is alpha in sentiment scores. The question is, can you get this into production? And that's the biggest question. And the last thing I want to show you is something very new. I was able to just get the demo up and running right before this presentation. I'm going to pull this up here. And that's introducing Finbert, which is explainability metric. Finbert is the sentiment scoring model that I'm going to be using, and that's actually fairly new. We released that for consumption. If anyone has questions about it, for helping us translate these into sentiments. So I'm going to actually tokenize. Let me actually tokenize all of them and generate a sentiment. So you can see here, it's actually generating a sentiment on exactly what I started with. In an unprecedented move, the NASDAQ has hit new records following the news of vaccine. So the question for us is, why is it choosing positive? And that's where I actually was able to calculate prior to this meeting to give us a feel for why. And all this functionality is now available in the latest release of MATLAB. So Shapley is there, Lime is there, and a variety of other metrics telling us that has hit news records today seems to be contributing in a positive way to the overall positive sentiment that we're seeing over here. So in summary, I'm gonna kind of end with one story. How do we enrich sort of the data science thinking with business insights? And I think this was a great example right here. There was an airplane that came back from war, and they had all these bullet holes. And so the statistician Abraham Wald was asked, where do we put the armor to kind of protect this plane? And so most of us would take the data, the dots that you're seeing over here, run it through some sort of analytical system, and then produce, hey, maybe we can put it over here, maybe we can put it on the wings. Turns out the recommendation was you actually put it in the places where there are no bullet holes. And the reason was the data points which we're seeing are actually planes that survived. And so when we start thinking about data and thinking about explainability, and we overfit our data to these, or overfit our models, the AI models to data, start thinking about where are there no bullet holes? Where is there no data? And start thinking about why is that the case, to really start helping the executives understand what is going on in the world of governance. And so if anyone has specific questions around governance, there's a lot of experience that the MathWorks has brought to the table. We do a lot of work in the aerospace, automotive, and defense industry. And so explainability, as you can imagine, with self-driving cars, fly-by-wire planes, rockets that go up to Mars, because of all the support there, we have explainability is mission critical in those industries. And so we're trying to make it more white box, because we've built a lot of requirements and validation, which actually produce governance documents over there. we're now starting to tackle the finance industry's SR 11.7, for example, governance, communications. So if anyone has questions around that, feel free to reach out to me, and I'm happy to help you start thinking about where we can kind of help you add explainability to your AI. So looks like there's quite a few people on here. Any questions? Because we're right at time right now.
I've not received any questions, Marshall, from the audience, but I'm sure they were just being shy.
Yep, no worries. There's like 99 people on here. So, all right. So if there's no questions, feel free to reach out to me, and I'm happy to follow up. And here's my email address if anyone needs that, or you can reach out to the account manager I work with very closely, Mike DeLucia. And I'm happy to take questions and really help shape your explainability with artificial intelligence. Thank you.
Thank you, Marshall. And audience, please do reach out to Marshall with any questions you might have. Marshall, thank you for your time. That was an excellent presentation.
Thank you so much. Bye-bye.